Let's do question number 27 of May-June paper 2, variant 1. Which row shows the conditions used for the conversion of sulfur dioxide to sulfur trioxide in the contact process? Now, to convert sulfur dioxide, which is SO2, it reacts with oxygen to form sulfur trioxide. It's a reversible reaction, so we need specific conditions to keep the system moving towards the right side, the sulfur trioxide side. So here the temperature we use is optimum temperature, which is 450 degrees Celsius. Pressure is of about 2 atm. And the catalyst which we use in the contact process is vanadium oxide. We use iron in the Haber process for the production of ammonia. So the answer is B. Next question. The equation for the reaction of magnesium with carbon dioxide is shown. Its statement about this reaction is correct. As you can see here, the magnesium is gaining oxygen as becoming MgO, and carbon dioxide is losing its oxygen and becoming carbon. So from carbon dioxide to carbon, it is called reduction because it's losing oxygen. And from magnesium to magnesium oxide, it's oxidation because it's gaining oxygen. Now, let's see the statements. Magnesium is oxidized and carbon dioxide is reduced. Magnesium is undergoing oxidation, so it is oxidized, it gains oxygen. And carbon dioxide is losing its oxygen and becoming carbon, so it's getting reduced. So option A is correct. In the other options, it's written that magnesium is reduced and carbon dioxide is oxidized, which is wrong. Magnesium and carbon dioxide are both oxidized, wrong. And magnesium and carbon dioxide are neither oxidized or reduced, wrong. A is the correct answer. Next question. Chlorine displaces bromine from aqueous potassium bromide. The ionic equation for the reaction is shown. Which statement about this reaction is correct? Chlorine, bromide ion, it displaces bromide ion and become chloride ion and bromine gas. Which statement about this reaction is correct? Bromide ions act as an oxidizing agent. Now, oxidizing agent is the one which is getting reduced. So bromide ions are getting reduced here or not? We have to look. Bromide ion is becoming bromine after losing electrons. It's bromide negative. Bromide is negative, and negative means it has extra electrons which it wants to lose. So bromide ion, to become bromine, it loses electron. So losing electron is called oxidation. So it means bromide ions are getting oxidized. They're not getting reduced. They are getting oxidized. So that means option A is wrong. Let's see option B. Bromide ions are oxidized as electrons are lost. So it's true because bromide ions, they're negative. Negative ions always lose their electrons to become neutral. And the loss of electron is called oxidation. The bromide ions are oxidized as electrons are lost. Chlorine acts as a reducing agent. To act as a reducing agent, it should itself oxidize. So it should be oxidizing itself and reducing the other. But over here, the chlorine is not oxidizing. Chlorine is getting reduced because it is gaining electrons. Chlorine is 0 and it is becoming chloride ion in the equation. So it means it has gained the electron to become negative. And gain of electron is reduction. So that it means that chlorine is getting reduced and not oxidized. So this is wrong. Chlorine is reduced as electrons are lost. Yes, chlorine is reduced, but electrons are not lost, electrons are gained. Half part is correct, half part is wrong. So this option is wrong. The option B is correct. Which gas is produced when ammonium chloride is warmed with aqueous sodium hydroxide? Now, sodium hydroxide is an alkali, or a base. Whenever they react with any ammonium salt, this is ammonium, and whenever base or alkali reacts with any ammonium salt, they produce another salt, water, plus ammonia gas. Ammonia gas is produced. So here, ammonium chloride, which is an ammonium salt, it is reacting with a sodium hydroxide, which is an alkali, and gives ammonia gas. Next, which equation represents a solution of ethanoic acid in water? As ethanoic acid is a weak acid, and all the acids are proton donors, so ethanoic acid CH3COOH, it loses proton, and CH3COO, ethanoate ion is formed. This is ethanoate ion. And the dissociation of weak acids is always reversible. So you have to make sure that correct the option in which the reversible sign is there, because weak acids ionization is always reversible. Number 26. 4 statements about the reactions of oxides with dilute hydrochloric acid and sodium hydroxide are listed. Which statements are correct? Let's read the statements one by one. Number 1, aluminium oxide, which is Al2O3. Aluminium oxide reacts with dilute hydrochloric acid and aqueous sodium hydroxide. Means aluminium oxide reacts with acid as well as reacts with an alkali. It's correct because aluminium oxide is amphoteric. So it reacts with both. Next, calcium oxide reacts with both hydrochloric acid and aqueous sodium hydroxide. Wrong. Calcium hydroxide is not amphoteric, it's basic. So it only reacts with acid, not an alkali. It only reacts with acid. Number 3, copper oxide reacts with dilute hydrochloric acid, but not with aqueous sodium hydroxide. It reacts with hydrochloric acid, but not with sodium hydroxide. This one is correct because copper oxide, again, the copper oxide is basic. So it will react with acid, but it will not react with sodium hydroxide. Sulfur oxide does not react with either hydrochloric acid or sodium hydroxide. This is wrong because sulfur dioxide, as I told you in the previous lecture, that sulfur dioxide is acidic oxide. So it reacts with sodium hydroxide. It will react with sodium hydroxide. Okay, so option 1 and 3, you're correct. B. Next question. Which statement about elements in period 3 of the periodic table is correct? Period 3 of the periodic table. Aluminium is a non-metal? No, aluminium is a metal. Argon is in group 8 and has 8 electrons in its outer shell. This is correct. Argon is a noble gas. Argon is a noble gas, and in its group, it has 8 electrons in the outer shell. This one is correct. Magnesium is in group 2 and has 3 electrons in the outer shell. Wrong, because the group number 2 means that it must have 2 electrons in the outer shell. D, sulfur is a metal? No, sulfur is a non-metal. Next question. Which row describes the structure of group 7 elements and the trend in their reactivity going down the group? Now, as we all know, the group 7 elements are called halogens. And all the halogens are diatomic. They do not exist in monoatomic form. So they are F2, Cl2, Br2, and I2. They exist as diatomic. So option will be option A or B. Anyone will be correct. Then, as for the reactivity, if we see the fluorine is gas, fluorine is also a gas, bromine is a liquid, and iodine is solid. So it means as we go down, the structure becomes harder and it will become harder and harder to react as we go down. So the reactivity decreases. Reactivity is how easy they react, the ability to react. And for the halogens, the ability to react decreases as we go down. Next question. Some information about 4 elements P, Q, R, and S is shown. Which statements are transition elements? Now, transition elements are hard. They have very high melting point and boiling point. They have high density because they're heavy, and they form colored compounds. These are some distinctive properties of transition elements. So, P, high melting point, high density, color of chloride pink. It might be. Next, Q, high melting point, density low, color of the chloride white. No, this is not a transition element. Next one, melting point high, R, melting point high, density high, color purple. Yes, P and R, A. Propanoic acid is a carboxylic acid. It has similar chemical properties to ethanoic acid. Which statements are correct? So propanoic acid is a carboxylic acid. It has similar properties to ethanoic acid. So ethanoic acid is a weak acid, so it means propanoic acid is also weak. Aqueous propanoic acid is a weaker acid than hydrochloric acid. Yes, it's a weak acid. Then propanoic acid partially ionizes in aqueous solution. Yes, because it's a weak acid, it partially ionizes. Propanoic acid reacts with ethanol to form propyl ethanoate. This one is wrong. Because when propanoic acid reacts with ethanol, the name will be ethyl. From ethanol, it will be ethyl. From propanoic acid, it will be propanoate. The name of the ester changes like this. So it will be ethyl propanoate, not propyl ethanoate. So it's wrong. 1 and 2 are